Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you are watching with me live or you're watching the recording later on. Right as we get started today, I just wanted to start out here with just a couple of announcements. Remember that your Module 2 assignments are due today or tonight by midnight. Right, remember that when we do these live streams, we're doing the live streams for the next module. Although it is a good time if you have questions to come in and ask them at the beginning of the live stream, and we can cover those questions as well. So if you have questions for the current module before it's due tonight or before it's due on Thursday nights, you can always ask those in the live stream at the start of the streams, and we'll cover those. Or you can just ask me via email, Teams, or whatever method you choose. So lots of options to get involved there. So that's our big reminder for today is that, Module 2 is due this evening, 11:59 p.m. We'll be grading them over the weekend, right? And that is another reminder, I think, to bring up as we are getting into this today is that, whenever you submit these assignments, make sure that you're looking at the comments. You should see a little, yellow speech bubble in your grade book there beside your grade. That indicates that there was comments left. And you would want to be able to have a look at that so you could see, some things that maybe you could do better or some things that you did well or whatever, right? And so today we're talking about a new concept, and we're talking about the concept of a function, right? And there are functions in a lot of different things, right? Like, there are several things in different disciplines that we call a function. And a function in programming is a similar thing to some of those, but it is a bit different. Right? So what we want to do is we want to make sure that we can define a function today, and then we'll move into talking about how we write them and how we use them. And we'll talk about two different types of functions that we can write in really any programming language. Are fruitful and fruitless functions, also called value functions and void functions. So that's our agenda for today as we are approaching discussing Module 3. So let's start off by talking about just what is a function. So a function is a named sequence of statements that performs some useful operation. So what we're talking about here when we say some useful operation, typically one of the things that we will do is we will use a function to kind of group statements together that perform an action, right? So if I have one function or one series of statements that does one thing, I'll put them together in a function. And this is going to help me modularize my code, right? Because I can kind of take these little individual statements and build them into like a building block. Right, we can kind of think of a function as like a little Lego piece, and we can take data and pass it into there, and take data and bring it out of there, and use that data for other purposes. Right, and so we can take this singular function and we can use it over and over and over and over again to similar or different ends, without having to write a whole bunch of code over and over and over again. Right, and so that's going to help us out a lot here. Now, functions may or may not take arguments as a part of them. We'll talk about what arguments are in a little bit, but one of the big analogies that I'll use here when we're talking about either side of this, arguments and the results that a function may or may not produce, is this idea of have you ever been to the bank? Right, you ever been to the bank and went through the bank drive-through and they have that pneumatic tube out there, and that pneumatic tube allows you to take something and send it into the bank, and then they can send you something out of the bank through that pneumatic tube as well. Right, we can think about our arguments here and the results that our functions could produce as that pneumatic tube. Because our functions are isolated, right? We're taking these functions, we're taking these bits of code, right? These lines these instructions, we're grouping them together, and we're putting them into a function, and that isolates those instructions inside of that function. And we can say that those lines of code are scoped to that function. So stuff that runs in the function only occurs in the function. It's kind of like what happens in Vegas, right? It stays there. So we need a way to be able to pass things in and take things out. And so we do that via arguments, and we do that via return statements, which we'll talk about a little bit later on. So, these are just things to kind of have in mind right now as we're going to approach these different topics. Now, you might be thinking, right? You might be sitting there and you might be thinking, well, why would I use a function? Like, what's the big deal of using a function? Right? Like, I can just take and write a bunch of instructions from top to bottom. Why do I need a function? Well, we got a lot of reasons for us to write functions, right? We've got 4 big reasons here. Because I know you're sitting there thinking, maybe you've already started reading Module 3 a little bit. You're sitting there and you're thinking, well, what exactly, why is this worth the trouble? Why is this worth the trouble of taking all these different lines of code? I can just write the lines of code in here and they'll work. What's the deal with all this trouble we're going into to separate these out and putting them into functions and then calling the functions and working with all that stuff? What gives here, Mr. Ramsey? Well, 4 good reasons here. 1, creating a new function gives you an opportunity to name a group of statements, which makes your program easier to read and easier to debug. So this is an instance where we're talking about being nice to ourselves as programmers again, right? Because we can have this group of statements that does this one specific thing, and we can put a name on it. So we know that if we go to test things later on, and there's something a little bit off with this particular process, or we, go away on vacation, forget about our program for a weekend or whatever, right? We can come back to it. We can see this block of code. We can see that it has a name, and we can know that all the code inside of it does a specific thing, does the thing that we named it, right? So this helps us to be friendly to ourselves in terms of writing code here. Another big thing is that functions can make a program smaller by eliminating repetitive code, right? And so that's one of the things you're kind of tasked with in the module for Module 3, right? You're asked to make a grid, but I put in there the challenge to make this grid as small as possible utilizing functions. And so we can take and we can write a whole bunch of statements, and we can write those statements over and over and over again. But in programming, as we are wont to do, right, we have a bunch of these acronyms that kind of help dictate the way that we code. And one of them is DRY, or dry. Right? We'll talk about writing dry code. You might hear programmers say that. I need to dry this code. And dry in this case is simply an acronym. It stands for Don't Repeat Yourself. Now, sometimes in programming, a little bit of repetition is unavoidable. However, we want to have this goal of dry as we're writing programs. We don't want to be really repetitive, and that's especially prevalent when we're writing big blocks of code, right? Like if you find yourself writing the same big blocks of code over and over and over again, that's especially one of those points where you think, well, I'd have probably been better off putting that into a function and letting that function do its job. Right? So we can run these same functions over and over again without having to write all the instructions in the code over and over again. We do that through a process called invocation, which we'll talk about in just a few moments. Dividing a long program into functions allows you to debug the parts one at a time and then assemble them into a working whole. And this is pretty great. Right? We actually have a name for this process as well. We call it incremental testing. Right? So each time we write a function, we can test that particular function. So we can just kind of invoke that function, run a print statement with that function, whatever we need to do. And if we get the right answer out of it, then we know that that function works and we don't have to touch it again. Right? And that's wonderful. And so if we can kind of chunk up our code like that, where we have one function doing a specific thing, however many lines of code that takes for that function to do that specific thing, and we can test those functions as we go through incremental testing, through just making these small increments, giving it a little test, and there we go. Then we don't have to make big fixes. We just have to make small fixes as we go along. Because I know some of you have probably had these issues as you're getting started here. Like you fix one thing, and then that reveals another thing. And when you fix that, it reveals another thing. And when you fix that, it reveals another thing. And so when you kind of wait till the end to do all your testing, that's the sort of quagmire you can get yourself into. Right? But if you're doing this incremental testing along the way, and you're writing these functions and you're testing these individual functions as you go, that's going to cut down on the number of changes that you have to make. And it's also going to cut down on the difficulty in trying to troubleshoot these fixes, right? Because you're going to be isolated to that function that you're working on at that particular time that is broken. Right? So that's a huge deal. And another thing, and we'll look at this a little bit more in the next module as well, is that when you write well-designed functions, you can use them multiple times. You can use them in other programs. So we can import them into other programs, or we can copy and paste them into other programs, and they'll work just fine. Right? And that's a huge deal. Remember, one of the things that we keep going back to is this idea that, programmers are kind of lazy, right? Like, it's like that old, might have been Bill Gates that said it. Like, if I'm going to give up, if I need to figure out how to do something, I'm going to give a lazy person the job because they're going to find the easiest way to do it. And, as programmers, that's what we kind of do, right? We kind of find the easiest way to do something because, well, we're kind of lazy. So if we write something that works one time, we can use that one thing that works over and over and over again in all of our programs. Whoops. I want to be here. Accidental click there. Whoopsie daisy. Goodness. Hey, stop for a second, PowerPoint. Let me take control of this. All right, we want to be here. Right, so once we write a program, right, we can use that program. We can use it multiple times. One of the things I like to say a lot is to let our past success influence our future success, and there's no reason to reinvent the wheel. So if we find something that works and it works well, we can just take this module, just like it was, this function, just like a Lego brick, right? And we can just take it from this one part and use it in something else. Makes life easy. Now, when we're writing a function in Python, there is a specific way that we need to write it. And it looks a little something like this, right? This is our basic function. So a function definition specifies the name of a new function, and the sequence of statements that follow execute when that function is called or when that function is invoked. So we have just a really basic, super simple example here. Right? We can write as many instructions as we want to in a program, in a function. But this is an instance of just a singular line of code. Right? And so we have def hello world with parentheses here, parentheses after it. Goodness, what is going on? I'm going to have to reboot after this live stream probably. And then we're printing hello world. Now there's a couple things to note here. Def, DEF, that's the keyword that we use to define our function, right? We're trying to define or write a definition for our function. The naming structure for our functions is the exact same type of naming structure that we would use for a variable, with one big exception, right? The same PEP8 rules, the same general, writing rules, right? Can't start it with a number, no starting it with a number, no symbols except for the underscore, so on and so forth. The big difference here is that with functions, we have to add this set of open and close parentheses at the end of it. Sometimes these parentheses will have something in it. Sometimes they won't. Right? These parentheses hold what we call arguments. And these arguments are, remember, we just used the word argument a couple slides ago. They're that, it's part of that pneumatic tube system that allows you to take values and bring them into your functions. And so another thing that we'll see here is we see this colon here. This colon is super important because we'll see this colon in other instructions in Python as well. When we see a colon at the end of a line in Python, that means there's more code that belongs to this statement. There's more code that belongs to this statement. And that's why in this second line here, we see this indentation. Right? This indentation here shows the relationship between this line of code and the line that comes before it that has the colon in it. Right? So if it's indented, then it belongs to this function. So it's a requirement that we indent our lines that are a part of a function, or a part of an if statement, a part of a while loop, a part of a for loop. Any line that has this colon at the end of it, if there's a statement coming underneath it that belongs to that, we have to indent it. And then when we get to a new line that doesn't belong to the function anymore, we backspace and unindent it. Right? Indentation shows relationships in Python, and it is requisite in the syntax. In other programming languages, we just use indentation for, kind of show, right? To kind of help keep our code organized. If you're not using proper indentation in Python, it will break your code, which is less than ideal. But let's just jump over to a Python window here, and I'm just going to escape out of this slide deck and open it back up, maybe to make PowerPoint a little more friendly to us. But we're just going to come over here and we're just going to write a function. And we're just going to see what we can do with this, right? So we'll just do a little example here that looked kind of like what we were using on the screen there. And then we'll modify that example just a little bit to do a little something else with it. Okay, so let's start out with a hello world program. We're going to start with our shebang here, right? Hash bang. Let's try that again. Hash bang /USR /BIN /env Python 3. And now let's write our function. So first we need our def keyword, def. And remember that is signifying a definition or the defining of a function. Now we can add our function name, which is hello_world. And we're going to put parentheses at the end of that. Parentheses indicate that it's a function. Even if you don't have an argument yet, you have to have those parentheses in there. The interpreter will be looking for those parentheses for functions. So you either have empty parentheses or you have parentheses with an argument name in it. And then the colon. And the colon indicates that there's more to this, right? There's more that belongs to this function. And now since we're using an IDE, since we're using an integrated development environment here on REPL, when we hit enter, it's going to do something nice for us. Look at where that cursor is. It's already indented that line for us. Right? Isn't that wonderful? We didn't have to think about indenting the line. It indented the line for us, so we can go ahead and start writing code because it's expecting more lines of code to be a part of this function, right? To be with this function declaration or function definition statement. So I can print hello world from here. Right, so now we have a function. But if we try to run it now, we'll encounter an issue. Right? In fact, I will do that. I'll go ahead and try to run it now and encounter said issue, which is nothing happens. Right? What we've done here, nothing happens. Right? Remember, we said that our functions are essentially the bank. This is a bank. We will signify that it is a bank by writing bank on it. And they're secured, right? It's, secured in air quotes, right? Like you can't see my fingers right now, but I'm making air quotes here. The things that go inside the bank are restricted to the bank. Right? So in order to get things outside of the bank, or in order to make things happen, we have to kind of go in or tell it to send some stuff out or what have you, right? So it's not enough just to create a function. This is good, but it doesn't do anything. We have to do a process called invocation. We have to invoke our function, right? Which is simply just writing the name of the function in our program. So one of the things we'll see here is that when I hit enter a couple times, I'm still indented. My invocation, I don't want it to be part of the function anymore. So I'm going to backspace this and go backwards. And I'm going to write hello world here. And so that's invoking the function. That's telling the interpreter to run this code and do this thing. So the interpreter knows, okay, I know what that is. I'm going to go up here. I'm going to find hello world. And I'm going to run that. And we get the hello world printed out to our console there the way that we would intend for it to happen. Now I want to run through some of this other stuff, right? Because I want to spend some time looking at a few other things later on. So let me just examine here my slide deck, see what we need to cover now and what we can kind of save. We'll throw a couple of these slides up there so you can see them, although a lot of this text is also included in your module there for you to read. For example, here, this is the Python formatting. That's going over the thing that we talked about there with the colon. The body of the function, the lines of code that belong to our function, they have to be indented. And the indentation illustrates that that content is part of our function. By convention, indentation is 4 spaces. However, with IDEs like Replit that we're using, or VS Code or whatever, we can get away with using the tab key because the integrated development environment understands that, this is a tab and it's going to interpret a tab as such. And so not only is this structure relevant for functions, but it'll be relevant for the next several modules as we're working with them, right? Because we'll need this sort of structure for conditionals. We'll need this sort of construction for loops and several other structures, right? And so when we get really deep into adding conditionals and loops inside of functions, we'll be getting, tabs that'll go 1, 2, 3, 4, 5 tabs deep, right? And so this is where it gets, or it can get, confusing to kind of make sure that all of our tabs are lined up with where they're supposed to be lined up to show the relationships between that statement and the other statements that are, related to other things. Right? So it's important to kind of understand the basics of this now before we get into the deeper stuff so we can kind of get the gist of what is going on. We also learned about invocation there from that first demonstration, which can also be termed as a function call. So in the context of programming, right, we have this sequence of statements that, performs the computation. That's a function. And this slide isn't finished. So, The function call is also the invocation where we had to put the name with the parentheses beside it. Speaking of those parentheses, let's talk about those parentheses. So as we've mentioned, the parentheses in our function declaration is for arguments. And arguments can be used as variables that are scoped for that function. And we assign that argument a value when we invoke the function or when we call the function. Right? So here we have another example of a hello world function. But in this case, we've done something different. Right? Instead of putting hello world inside of this function, we've put this argument here, this argument of x. And then instead of printing a string, we're telling our program to print x. So x can be anything. Right? This is that pneumatic tube. Right? This is the structure that allows us to take things from outside of the bank and bring them into the bank. So in this instance, we're telling our function what we'd like to send in when we invoke it. When we invoke the function, hello world. And so what happens is, we've got this function invocation here. It's going to grab this hello world here, take it, put it in here, into the value of x, which in turn will pass it through the program as x. So this is exactly the same as just printing hello world. but it gives us more flexibility. So as we've mentioned, when we see an empty parentheses, that means there's no arguments for this particular function. And in terminology, we say that a function takes an argument. So let's have a look at that in our program now. Find that replit window here. And I'm just going to comment out this function that we've already done here. Or really I can, I'm going to comment out the whole thing. And we'll do this again with the argument method, right? So we're going to create our function. Right, keyword def to define a function, def. We're going to give it the same name, which is hello world. But this time we're going to put an argument inside of this parentheses, and I'm going to call it message, or MSG. Right, and so this gives me the means through this argument to take a value from outside of this function and pull it into this function. Which is pretty significant, right? So we can take something from the outside and bring it in. And so we'll print MSG. And that's our function. Right, so now we're ready for the function invocation. We're ready to call this function. So when we call the function now, so we can get it to work, we're going to call it by name. So it's hello underscore world. And then we're going to put the message that we want to send into this function inside of a string in between these parentheses, like hello world. And so when we run that, that's going to take hello world. That's going to pass it through, the whole pneumatic tube thing. It's shooting it up the tube. It becomes message here and message here. So we print hello world, right? Since we didn't change the message there, it looked the same, but we'll clear out our console there so we can see that work again. So what's the benefit of this? Right? If we can do it this way, like we've done up here in lines 3 through 8, why would we want to do something like this? Well, maybe I don't want that to be my message every time. Maybe I don't want it to say hello world every time I invoke this function. Maybe I want to be a bit more casual. And I pass another string through there. So maybe instead of hello world, I just say hi planet. And we run that. And we see we kept this function invocation still in here. So our first line on our output here is hello world. But now we have a whole other function invocation here. And it's printed that out as well. And I can do this as many times as I want with as many values as I want. And it's going to do the same thing. It's going to take the message that I type into here. It's going to take that value. It's going to put it in the argument of MSG. And then it's going to pass that into the function. And that MSG is only used inside of this function. It doesn't mean a bit of difference anywhere else, right? Like if I tried to print MSG, it's going to give me a problem, right? We see that little red squiggly line there. It doesn't know MSG, right? Because MSG here is only inside of the bank. It's not outside of the bank, right? MSG is only inside of the function. It's not outside of the function. So if we tried to print MSG, it doesn't exist outside of that function. So let's do something else here. Let's take what we know right now and write a little program with it. Let's take and make a 4-function calculator where we can take 2 numbers bring them in, and it will take those two numbers and it will automatically add them, subtract them, multiply them, and divide them. And so since it is good practice, what I want to do is I want to start this by kind of sitting down and thinking through my problem. Right? So what I want to do is I want to have one function for one action. So that's one function for add, a second function for subtract, a third for multiply, a fourth for divide. And if we wanted to get really fancy with it, right, we could even do, maybe like a fifth for, our exponent notation that we learned, and even a sixth for our modulo. Right, so since we're doing one function for one action, we'll have one function for each of these. And then we'll get a little fancier with it from there. But before we do that, I want to bring something to your attention, which is the idea of fruitful versus void functions. Right, so fruitful functions we also call value functions. Void functions we also call fruitless. Functions. So in the context of what we've been doing so far, everything has been a void or fruitless function. And so why is that? It's because we've taken data and we've passed it into the bank, right? We've taken data and we've passed it into our function, but we haven't taken any data out of our function. Like we've printed information to the console, but we haven't returned any information that we can otherwise use in other calculations, computations, functions, whatever, right? If we use a fruitful function, then we're returning a statement using our return keyword. And in doing so, we're returning a value that we can use in other things. And so we can write functions both ways, right? We can write them self-contained where they're printing inside of themselves, right? Or we can write them as value functions or fruitful functions that are going to, they're going to use that pneumatic tube again and send data out of them that you can use elsewhere. Right? So the difference here is that essentially, we call them fruitful functions because they produce fruit, and you can take that fruit and use them in, other calculations, computations, something else, right? Which is why we say that when we use these fruitful functions, you almost always want to do something with that result. And so these void functions, when we just write the print statements and just print the output directly to the console, it stays in the bank. It doesn't send anything out, right? So we can't do anything with the values that we've seen in there. It's just like, using that MSG argument, trying to use that as a variable outside of that function. It's not scoped for that. It's not going to let you do it. Right? So let me show you what I mean here. So I'm going to take and I'm going to move down the comment here. Let's clear out this console. And this time I'm going to write a fruitful function. And I'm just going to go ahead and write my add, right? You know, we said we were going to do all that stuff with the add, subtract, multiply, and divide. I'm going to go ahead and write my add. So I'm going to define an add function. And we're going to bring in two values here, num1 and num2. And we're going to put that colon there at the end. This is a good time to point out that we can have as many arguments as we want going into a function. I just need to separate them by commas. And then when you invoke that function, when you call that function later on, the position of the pieces of data that you put into that function call is which argument that piece of data is going to take the place of, right? So if I did add 2 comma 3, num1 would be 2, num2 would be 3. Add 7 comma 2, num1 would be 7, num2 would be 2, so on and so forth, right? So what I'd like to do here is I'm just going to create a, kind of an in-between variable here that will give me the result of num1 plus num2. And I'm going to return that value. Right? And instead of x here, let's use something that's more descriptive. Let's call this result. So we're going to return result. So watch what happens with this when we call it. Add 3 comma 4. Nothing. This is a value, right? We have the value somewhere in memory of 7. But it doesn't, we haven't told it to print it, right? Like if we said x equals add 3 comma 4, the way we've kind of done some things in testing in the past with our console only here, and then got our console to evaluate x, we see that that's 7. So we are getting a data value from this, but we're just getting the data value. It's returning the data value. So we just have a 7 here. So in order to print this, we might want to add this to like a variable. Say maybe add result equals add 3 comma 4, or print add 3 comma, we'll use a different one here, 9. And then we could also print add underscore result. So in this first instance here, it's returning the value. That value that's getting returned is the value that's leaving out of the function. So it's the value that kind of replaces this function invocation after it's done, right? So we may as well look at that as 7, right? Like we can kind of break that down in that sort of way. Let's have a closer look. Right, so when we get here, we get this invocation of the add function with 3 and 4. And so it's taking 3 over here, putting that into num1, because that's the first one in the order there. It's taking 4 over here, putting that into the num2, because that's the second one in the order in both places. Then it's going to transfer that to each of the places. Do the math. Take the math, put it into the result. And then that result leaves the bank and goes back out. And so it's almost like we took this here after we ran this function and got the result, crossed this out, and just replaced it with the value that is the result, in this case, which is a 7. So all we did basically was take We made a variable here. We established that container. We put the label of add result on it. We did this whole process with the function that we just talked about, and we put the value of 7 in that container so that, when we use that variable later, it'll print 7. So what we should expect here is we should expect to get the result of this function first. So in our console, we should see 12 first, 7 next, and that's what we should expect to see with this. So let's run this, 12 and 7. Beautiful. So our arguments give us that ability to take and bring data into a function. Our returns give us something to take out of the function. Now you can only return one thing. So when we're returning something, we can only return one thing. So we can only send one thing out. Right? Because ideally that's the data cycle too, right? We're only going to want to send one thing out. Right? We've taken that data in, we've ran it through a process, and we're going to output it. We're going to output the result. But another thing to note with this return is that when my interpreter hits that return and it sends that data back out, that function is over. It's finished. It's not going to do anything else. If I put a little print statement here beneath it, that's unreachable code. That will never be sent out. It's unreachable, right? If we tried to run it, we still get 12 and 7. It never touches this. Now I could move it before that, right? I can print something else here before that return, and it'll do that. Reachable, reachable, right? It's reachable. With that statement that comes after the return, that is unreachable. It'll never get executed if it comes after the return, because our interpreter stops messing with the function when it hits that return statement. Because it's, as far as it's concerned, it's done, right? Just like at the bank, when the bank sends you back out your stuff through the pneumatic tube, right? You're done. Your business is complete. Take your money and go, right? That's what's happening here. We're having to take our money and go. So now that we have this, we can kind of continue on with that program that we were talking about we were going to do, and we can do it relatively quickly here. And so we have an add function. And we can basically just kind of take this and copy it a couple times just for the interest of time here. Right? So we want add, we want subtract, multiply, divide, exponent, and modulus. Now you see we have all these green lines here because we've used the same function name more than once. That's a big no-no, but we're going to go through and we're going to change all these names, right? So this will be sub, this will be mul, this will be div, this will be exponent, exp, and this will be mod, mod. And so I can use the same variable names in all of them. I can use the same argument names in all of them because remember, they're scoped to that function. So they're not going to get confused, right? I can also have them be anything I want to be. Like one of the things that I did in the seated class this semester, just to kind of prove that it doesn't matter what these are called as long as we're consistent with them. I called one tree, I called one like flower. And then I called the result like maybe like apple pie. And so as long as we're consistent with what we're calling them here, doesn't matter what we call them. We'll go ahead and change this to times. And then we'll return apple pie. Although you can probably see here, right? One of the big reasons why we want to name our variable something that is understandable is because, would you necessarily know what you were looking at if you came to this little function and it, was looking at tree times flower equals apple pie? Probably not, right? But if it was number 1 and number 2, you might be able to handle that. So let's change these mathematical operators here. So that's going to be divide, that's our exponent, so that's asterisk asterisk, and then modulo is our percent symbol. And so we're returning all of these values, right? And so what I'd like to do in returning all these values is I'd like to be able to write another function that's going to invoke all of these individual functions so we can do everything at once, right? So we can write another function and call it complete calc. And we're still going to take in 2 arguments here. We'll call them num1 and num2 still because we're on a roll. Right, and so what we'll do here is we will print add num1 comma num2 and we'll just do the same thing there. So this will be sub num1 num2 mul num1 num2 div num1 num2 exponent num1 num2 mod num1 num2. Right, so now when we invoke this function, we're going to pass into it a singular, 2 arguments, one for number 1 and one for number 2. It will in turn distribute all of those, it'll distribute those numbers, right, into all of these function calls when it goes to print them. And it will run all of these functions with those numbers that we distribute in there and print it out as a result. So all we need to do here is invoke this function, complete calc, with 2 random numbers, let's say 5 and 3. And look at our results. There we go. We get all of those results there. 8, 2, 15, 1.6 and continuing, 125 and 2. Right, and so if I want to evaluate this with 2 different numbers, I can just run that function again. Complete calc with 2 completely different numbers. Maybe like 18 and 4. So the first 6 here are the ones from the previous function, the ones from this function. The second 6 are the ones from our other function. And we can see those values there. Right, and that's significant. There are several things to point out here. Right, since we set this up this way, like it would be easy enough just to print out the results of these statements. Right, and just go print num1, print 5 plus 3, print 5 minus 3, print, right? We could do that over and over again, right? But that's going to take a lot of code to do. And then if we want to change those numbers to test and evaluate 2 different numbers, we have to change every instance of 5, we have to change every instance of 3, or write all of those functions again. Or rather, write all those instructions again. By using functions like this, we can write our functions one time And we can just, after that, we can reuse them over and over again by just adding a single line of code. And it'll do everything that we want it to do. So that's super significant, right? Super significant. Now, as we're wrapping up here, we don't have much long left. I did want to show you all Python's math functions. Python's math functions. So some of the things that we do, right, are built into other functions in Python. And so Python has math functions that's already built into the library, right? We talked about, like week 1, week 2. We called Python a batteries included programming language. And that means that it has other libraries of other code in them that does things. And those other libraries of code are essentially just a file full of functions that you can run from there. Right? And this is actually a process that we call abstraction, the ability to refer to another function that exists somewhere in the program without actually having to know what it does or how it's written. Right? That's abstraction. And so in Python, we have the math function file that allows us to perform a certain set of functions. All we have to do is import it. Now, the easiest way for us to kind of look at math functions is through the documentation. So if I type in Python math library, the very first results, or the very first result here, that's the documentation for the Python math library. So I'm going to give that a little click. And here we see a bunch of really valuable things that we can use to help us do some complex calculations. Math.ceil. If we run that function, it's going to round up a floating point or decimal number to the next whole number, right? So if it's like 2.73, it'll round it up to 3. If it's 2.14, it'll round it up to 3, right? It's rounding it up to the ceiling. That's why we call it ceil. We have math.factorial, which I actually did the factorial algorithm with my seated students this morning, but we actually didn't have to do that because it's already included in Python, although it is a good idea to know how these things work, of course. So you take the factorial there, like if I took math.factorial and put 5 in there, it would run 5 times 4 times 3 times 2 times 1. We'll look at how we actually write that algorithm in a future class. Math.floor is the opposite of math.ceil. So it takes it and rounds it down to the previous whole number. So 2.75, whatever, would round down to 2. 2.12 would round down to 2. Right? It's rounding it down to the floor instead of rounding it up to the ceiling. And there's all sorts of stuff that you can kind of just look through here, read through, see what might be relevant to you. Like I believe we have some trigonometric functions in here, because I think we have things like, log. We have square root in here, which means if we use this, we won't have to do to the power of 0.5 like you were doing in the math in the previous module. Cosine, sine, tangents. Working with degrees and radians, right? We got the ability here to kind of do some mathematical functions, right? Do some complex math here. In addition, we have some constants, and these are these common values that are used to precision. Right? So instead of just saying, oh, we're going to use 3.14 here for pi, like I think we've done in the past, we can use math.pi, and that'll give you the most precise value for pi available in Python. Same thing here with all this other stuff. So if we just kind of jumped over back into our Python REPL here, which it's already on this screen, I just have to click the tab. I'm going to comment out everything here that we've done so far. So you'll want to uncomment this when you go to work with this. But the first thing that I need to do is import this. So I can import math and do that here at the top of my REPL. And so this is significant because, like, even though it's included in the code base, we don't need it every time we run a code, right? So we have to import it instead. It gives us the option to import it instead. That way, right, instead of having to load these functions every single time that we might or might not be using, we can only load them when we need them by importing them. And so I could go down here and we can, like, just do these functions on anything, but we'll just kind of do some quick examples here. And so we refer to the library. In this case, it's math dot, say, seal, the function that's within the library. And then we put our value, something like 2.124 in there. And so we should expect this to print out 13, which it does. Right? We could do the same thing with something like math.floor. We could print out our pi constant to see how precise that is. One of the things that's interesting here is that you actually don't need to do any of the stuff that we did in the labs for the last module, because there's a little something called math.hypot, which will find the hypotenuse of a right triangle given sides A and B, so something like 3 and 4. Right? You know, it's worth your time to look into this math library and check out the functions that are in there. And if we run this, we should expect 13, 12, the value of pi, 3.14159, whatever, and the hypotenuse of a 3, 4 right triangle, which should be 5, or in this case, I think 5.0, is what it'll return to us. So we can run these and see all this stuff. 13, 12, 3.141592653, 589,793, and 5.0. So that does a lot of work for us that we don't have to do. And we could even make this shorter. Right? Because if we're importing a library, we can also import that library with an alias. So I can say import math as M. So now I don't have to type the name math anymore when I'm referring to that library. I can refer to it by its alias, in this case, which is M. So I can say math.seal. Or instead of math.seal, I say m.seal, m.floor, m.pi, m.hypot. And everything's still cool. But unless you put that alias there, it won't know what M is, or it won't know whatever else you want to call it is. Right? It only knows the math library. We'll look at another library a little later on into the course when we get into working with CSVs. But for now, this will be it. And we've gone over our time here for today, so I want to go ahead and stop here. This pretty much covers everything that I want to cover anyway. You know, it's a good thing to point out as well. Like, I go a little bit faster in these streams unless I have people stopping me with questions in chat. Because, if you're watching the recording, you can always pause and rewind, which is a lot different than class, right? Like if we're in class, you can't necessarily pause and rewind me. But if you're watching this video here, you can pause, you can rewind, you can do that several times. And, I recommend doing that, like if you have trouble catching something at first, right? So there is that. But this kind of covers all the big things that we need to kind of cover in terms of making things work in this module. You've got some great challenges set out ahead for you in your labs for this module. I'll hang out in chat for just a couple minutes to answer questions if anybody who's here with me live has any questions. If you're watching the recording and you have questions, feel free to email, feel free to Teams. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.